Now guys, next topic જોઈશું. Obtain the formula for AC voltage applied to capacitor. પહેલા આપણે જોયું એ ઇન્ડક્ટર વિશે જોયું. હવે શું જોઈશું? Obtain the formula of current for AC voltage applied to a capacitor. And draw the graph. Now guys, પહેલા આપણે ઇન્ડક્ટર વિશે જોયું. હવે કેપેસિટર વિશે જોઈશું. A pure capacitor connected in AC circuit is shown in figure. In shown in figure guys, capacitor is connected to AC voltage. Okay. Now guys, voltage V is equal to Vm sin omega t. Okay. When a capacitor is connected to a voltage source in a DC circuit, current will flow for the short time required to charge the capacitor. As the charge accumulates on the capacitor plate, the voltage across them increases opposing the current. When the capacitor is fully charged, the current in the circuit falls to 0. Now, when the capacitor is connected to AC source, it limits or regulates the current but does not completely prevent the flow of charge. Okay? The capacitor is alternately charged and discharged as the current reverse each half cycle. Now let Q be the charge on the capacitor at any time t. The instantaneous voltage V across the capacitor is V is equal to Q by C. We know that Q is equal to CV. So V is equal to Q by V, where C is the capacitance, C is the capacitance of the capacitor. Now V is equal to Vm sin omega t. Put the value of V is equal to Vm sin omega t in this equation. We will get Vm sin omega t is equal to Q by C. So CVm sin omega t is equal to Q. Now I is equal to dq by dt. So I is equal to d by dt. Q ની વેલ્યુ કઈ છે? આઈ રહી CVm sin omega t. So guys, I is equal to Vm c omega cos omega t. Derivation. So I is equal to Vm upon I upon omega c into cos omega t. Now putting cos omega t is equal to એનું સાઇનમાં કન્વર્ઝેશન કરીએ. cos omega t is equal to sin omega t plus pi by 2. Okay. Where Im is equal to I is equal to Im sin omega t plus pi by 2. So guys, Im is equal to Vm upon I upon omega c is the amplitude of oscillating current, is the amplitude of oscillating current. Okay. comparing this equation to I am is equal to compare this equation I am is equal to Vm upon R. 1 upon omega c plays the role of resistance. It is called capacitive reactance and it is denoted by Xc. Capacitive reactance. So guys, Xc is equal to 1 upon omega c. So that the amplitude of the current is Im amplitude of the current Im is equal to Vm upon Xc. Okay guys, a comparison of V is equal to Vm sin omega t and I is equal to Im sin omega t plus pi by 2 shows that the current is pi by 2 ahead of voltage. Okay, and its figure V versus I explain the figure. This is the figure V versus I. Okay, this type of figure we will get. Okay guys, phasor diagram at instant t1. ઓકે, તો પહેલાં આપણે કેપેસિટન્સ માટે જોઈ હતી ફિગર, હવે રેઝિસ્ટન્સ માટે જોઈ. ઓકે, થેન્ક યુ સો મચ ગાઈસ.